Hi, I'm John,
I'm Hillary.
and we're going to talk to you about syntax exercises in CS1. The first question is, what are syntax exercises?
Let's see. Longboarding with Mario in 15 minutes. But I gotta get my syntax exercises done. I got time.
Okay, here we go. Here, run the code, change it so that it outputs 0, I don't know, let's just look at the code. For I in range 0, 3, I have no idea what that means. Let me just run it here. Didn't pass, but hey, look, it outputs 0, 1, and 2. So, let's see, so now I need it to print 0, 1, 2, and 3. It says I need to change the 3 to a 4. Okay, so I can do that. 3 to a 4, run it. Bam, okay, next one, next. This code has a for loop. Change the code so to output 0, 1, and 2. Well, it's pretty much the same. Let's see, add an argument to the range call to output 0, 1, 2, 3. Okay, so I gotta start filling stuff in, so 0 to 4. Cool. Write a for loop. Okay, so now I gotta write a whole for loop. For I in range, let's see, range 0, 4, and print I can do that. Fix the bug. Change only line 2. Okay, so I gotta change that to count. Sweet, congratulations, I'm done. I even have time for a quick sandwich.
Johnny, what were you working on?
For loops?
What are those?
I don't know. But I just wrote like 20 of them. And I hardly made any mistakes.
You don't know what they are? Don't you think you should read about what they are?
Nah. Professor Edwards will explain it tomorrow in class. I gotta go. Bye.
Your helmet!
Oh, right.
Loops are used when we want to do something multiple times. For example, in this code, we draw a circle 4 times. Let's see. So, for I in range 4, so it's going to loop 4 times, just like in the exercises. Yeah, that makes sense. In your assignment, due next Friday, you will need to draw a dartboard. This will require you to draw 5 concentric circles using a for loop. Okay, so I need to draw a dartboard with 5 circles. So to draw 5 circles, he said I need to use a for loop. Oh, I can write a for loop. For I in range. What's the problem? I've been working on this for 2 hours. Oh, the tutor responded. I'm missing a colon after range. I wasted hours on a stupid colon. Let's see. Error on line 2. Oh yeah, the colon's missing. I saw that a couple of times in the syntax exercises. As we see, syntax exercises are designed to encode a student's ability to type syntactic constructs into procedural memory. There are goals in doing this. The first goal is to decrease student frustration with the so-called missing semicolon problem. The second goal is to scaffold learning of problem solving with proficiency in syntax. You'll recall in our earlier vignette that Johnny picked up on the professor's code quickly. He was able to pick up on what the professor was trying to teach more quickly because he didn't have to spend time bogged down in understanding the syntax. To investigate the idea of syntax exercises, we developed a piece of software called Fanon. Using Fanon, we conducted a controlled study at Utah State University with over 500 participants. We'll state our 3 research questions and summarize our results.
Research question 1. How does a syntax-first pedagogy affect student attrition? This chart shows a measure of attrition over the course of the 5 programming projects the students did during the study. Each line shows the percentage of students attempting the projects. The blue line shows the control group, who did not have syntax exercises, and we see that the number of engaged students after Project 6 declines rather dramatically. We note that Projects 7 and 8 are quite a bit harder than the first 3 projects. From the orange line on the chart, we see that the test group had more success in retaining students, with 97% of students attempting Project 8 compared to the control group's 94%. We'll need more data to make any strong claims, but it looks promising.
Research question 2. How does syntax pedagogy affect project and exam scores? We had a bit of a surprise on this one. Project scores actually went down. Not by much, but they decreased. You can see from the table that every project scored higher among control students than test students. For example, the average score for Project 8 in the control group was 79, while the test group average was 78. Statistical significance was very low, so we can't read too much into it. But the next surprise is that while project scores went down, exam scores went up. And not by a little. The average score on Exam 1 went up by 7% when students had syntax exercises. This is a bit of a puzzle, and we'll talk about what might have happened in a minute.
Research question 3. How does a syntax-first pedagogy affect the time required for students to complete programming projects? Again, we were surprised. Students who had done syntax exercises actually need more keystrokes to complete their projects. You can see the distribution here, where the test students in orange had a median around 7,000 keystrokes for Project 8, while the control students only needed around 4,000. So, introducing syntax exercises actually increased the amount of effort students went to complete their projects. This is another riddle.
The key to unraveling what is going on here may be at least partly answered by the spike of students with close to 0 keystrokes. Look at the blue bars near 0. These are students in the control group that typed very few keystrokes on Project 8, and there are a lot of them. That's weird because the control group got better scores on average than the test group. How did students who put hardly any effort into their projects score so well? The Fanon software is how we collected keystroke data, so it appears that the code for the control group is being written outside of Fanon and then pasted in. So why did so many more control group students paste their code into Fanon than students with syntax exercises? We go into a couple of explanations in the paper, one of which is plagiarism. Could it be that the test group, or the students with syntax exercises, are plagiarizing less? That would explain the increase in keystrokes, because students who would normally plagiarize are requiring more effort to complete the projects. It would explain the lower project scores, and it would explain the higher test scores. Since the students are doing their own work, they're better prepared for the exams. While we discuss other possibilities in the paper, a reduction of plagiarism has important enough implications that we feel it should be further investigated.
So, what are some of the implications of this work? First, some practical implications. Syntax exercises take students, on average, 24 minutes a week for a 3-credit-hour course. Unless the time requirements for the programming projects are very high, this means that syntax exercises could be added with little to no modification to existing programming projects. Furthermore, instructors can reuse and share syntax exercises, since it's really more work to cheat on the exercises than it's worth. So, just adding syntax exercises to an existing course is a possibility, and if it does, in fact, reduce plagiarism and increase exam preparation, then it seems well worth the effort, especially with the high failure and attrition rates of CS1.
But there are also some really interesting research questions that this brings up. Why would attrition rates go down? And if syntax exercises really do reduce plagiarism, why? As importantly, we note that many instructors would consider exercises targeted at syntax to be not worth the time. After all, problem solving is the most important thing to be learned in CS1. Why would we spend so much time on syntax? It's all about cognitive load. Giving students fluency in the syntax allows them to allocate cognitive resources directly to problem solving. We really are scaffolding learning with syntax. Replication studies are needed to confirm and expand our findings, and to better understand the underlying cognitive and attitudinal principles of the results. Thank you for your attention.
Thank you.
Sweet. Done. Even have time for a quick sandwich.